Hello and welcome to another weekly recap. We're up to recap 14, and today we are going through speed, distance and time, converting between those, scatter graphs, travel graphs and conversion graphs. So before we start though, let's make sure that we've got our heads in order. So we've come to this video because we want to get something out of this year. We want to do better than we did last year. We want to keep improving, and we're going to get there by working really hard, revising these videos regularly, coming back, and let's start. So when we're working on speed, distance, time, there's an ingenious button that we can use to help us work with time, and that is this button down here. So this button here helps us to convert between hours, minutes, and seconds, and I'll be able to use that on the calculator. So if I want to show 2 hours 15 minutes on the calculator, what I'll do is I'll press 2 for 2 hours, then I'll press this button, and on the calculator it'll bring up a little square like that. Then if I want 15 minutes, I'll press 15, and then I'll press this button again, and it'll come up on the calculator. So this is actually saying on my calculator 2 hours 15 minutes. The reason this is useful because on my calculator works in hundreds, tens, hundreds, thousands, so like powers of 10. But this, we know time works in 60 minutes, 60 seconds, 24 hours, things like that. So this button helps us to calculate with time. So we can use this button to work out times. So if I want to show 5 hours, 12 minutes, 25 seconds, I press 5 for the hours, press the button, 12 for the minutes, press the button, and 25 for the seconds, and press the button. You have to press the button after every time you press an hour, minute, or second. Okay, make sure you do it at the end, otherwise it's going to give you an error. 35 minutes would be 0 hours and 35 minutes. And the button again. 15 seconds would be 0 hours, 0 minutes, and 15 seconds. The calculator also allows us to turn decimals into time. So if I do a sum, and the answer is in time, and I get 6.5, what I do in my calculator, I press 6.5, I press equals, and then I press this, we'll call it the time button from now on, the time button, and it changes it into 6, 30, and then 0. Okay, and we can turn that into 6 hours, that's the equivalent of, you'd write in your exam, 6 hours and 30 minutes. Okay, if you did 8.3, so you press, if you got an answer and it was 8.3, you'd press the time button again, and it would come out as 18, 0. And that would be 8 hours and 18 minutes. So that's if you get a question and it says leave your answer in hours and minutes. You can just get the answer in a decimal, press the time button, and it will turn it into hours and minutes for you. Okay, this is a really good, useful tool to help us on this next topic. So we're going to look at speed, distance, and time. So how this appears in the exam, it might say speed, and that means how fast. Distance is how far, and time would be how long. So if a question said, for example, how fast was someone traveling, that would be speed. If it's saying how far did they go, it would be distance. And if it said how long did it take in hours and minutes, that would be time. And we use this triangle to work out each one. So if I want to work out speed, I'll cover up S, and I'm left with D above T. So D above something, or anything above anything else, is, we say over when we're talking about a fraction. So D over T, and that line, remember, means to divide. So speed is distance divided by time. Distance, so if you move the circle over the D, we've got D, S, and T. So distance is speed multiplied by time. And time, if you wanted to calculate time, cover up T, we're left with distance over speed. Okay, so let's do a bit of practice on this. So here we go. A car travels 200 miles in 4 hours. How fast did it travel? So how fast, that means we're looking for speed. So speed is equal to distance over time. The distance is 200, and the time is 4 hours. So you can put into calculator, you can even use the time button there. So 4 hours. So 200 divided by 4 hours equals, and it'll give us an answer of 50. Okay, and the unit for that, if we're talking about how fast, is going to be, well, it's in miles and hours, so miles per hour. Okay, a car travels at 30 miles an hour for 5 hours and 15 minutes. How far did it travel? So how far, that means we're looking at distance. Distance is speed multiplied by time. So we're looking for the speed, which is 30, and the time is going to be 5 time button, 15 time button. So 30 times 5 time button, 15 time button equals, and then it gives you a bit of a weird number on your calculator, but if you press the SD button, it'll turn it to a decimal, and how far did they travel? That's 157.5, and because we're in miles per hour, the answer is going to be 157.5 miles. Okay, if you get a weird number and you're not comfortable writing that down, press the SD button until you get a decimal or a fraction until you're happy with what you want. Okay, the SD button is this one. Oh, this one here. Okay, a car travels 145 miles at 50 miles an hour. How long did the journey take in hours and minutes? So how long did it take? So we're talking about time. So time is distance over speed. The distance is 145 and the speed is 50. So 145 divided by 50 is 2.9. Okay, so 2.9 is not hours and minutes. That's not 2 hours 9 minutes. That's not 2 hours 90 minutes. Okay, so what we need to do, once we get that 2.9, if you press your time button, it converts it into 2 hours 54 minutes. Okay, well, it actually comes out as 2:54. Okay, but you convert that to 2 hours 54 minutes. Okay, scatter graphs. So scatter graphs show correlation. So whenever we're talking about two things that have a relationship, are related to each other, we're talking about scatter graphs. My advice when dealing with scatter graphs, the first thing you want to do, as soon as you see one, you want to draw a line, what's called a line of best fit, from going through your points. So giving a general trend through your points. So for this one, a line's going up, and this one, we've got a general line that goes sort of an equal amount of stars or crosses on each side, and just a general idea. It doesn't have to start at 0, 0. It doesn't have to start there. I usually start mine just next to the first point and then draw it through. If the line is sloping upwards, we call that a positive correlation. Okay, the line is going up, we call it a positive correlation. If the line is sloping down, so even if it's sloping down slightly, we still call it a negative correlation. So a line going upwards is positive, a line going down is negative, and if the points are all scattered around, it's a scatter graph after all, then if there's no real pattern to it, we say no correlation. If we have a point that doesn't sit with all the others, so if we had like a cross there, for example, we would call this an outlier. Okay, so this would be an outlier, something doesn't fit with the rest of the pattern. Okay, and generally we would ignore that, but in the exam sometimes it says circle the outlier, so all you do, just circle that. Okay. So here we've got a scatter graph. First question is usually the same, this is going to be one of the questions when you have a scatter graph. Remember, a scatter graph, you don't want to be joining up all the points. If it starts looking like this, then maybe think again, or maybe I've made a mistake. Remember, you don't join up the points when you're doing a scatter graph. You draw, what I said before, is a line of best fit. So a line to start next to your first point and draw a line roughly going through the middle of your points, so maybe down like that. Okay, so that's my line of best fit. What type of correlation? Well, the line is sloping down, so we're going to say that's a negative correlation. A different car of the same type has an engine size of 2.5 litres. Estimate the distance travelled on 1 litre of petrol from this car. So you find 2.5 litres on your graph, and you draw a line up to your line of best fit. So it hasn't mentioned draw a line of best fit here. That's my advice. Whenever you see a scatter graph, you automatically draw a line of best fit. So my line's going up from 2.5 to my line of best fit, and then across, and it's about between 10 and 12. So the number that springs to mind when we think between 10 and 12 is probably going to be 11. Okay. Another example. So again, doesn't say anything about line of best fit in the question, but my first thing, just next to my first point, up to my last point, just sort of trying to get an equal amount on either side. And let me just change this into a solid line. So that's my line of best fit. Again, you don't get any marks for it, but it is going to help you later on. So on the scatter graph, and this is a part that people overlook, so be very careful, this part A. The table shows the height and weight of 3 more students. So this is a graph showing height and weight of students. On the scatter graph, plot the information. So make sure you don't ignore this. This is a free mark, really. 135 and 70. So we're just going to plot these on. 135 and go up to 70. 155 on the height and 75 on the weight. 155 and 75 on the weight. And 170 on the height and 85 on the weight. Okay, so we plot those on. So that's a free mark, really. Just plotting 3 points, nice and easy, and that's done. Okay, we've got my line of best fit. What correlation? Well, the line is sloping upwards, so it's positive. And then we can use our line of best fit to answer part C. The weight of another student is 80 kg. Estimate the height of the student. So 80 kg. So we're looking at the weight. So on this side, here's weight, 80 kilograms. We go across to our line of best fit. And we come down to our height. So I think each square here represents 1. So we've got 60, 61, 62, 63. So 163 centimeters. Okay, you do get a little bit of leeway, because obviously everyone's line of best fit will be slightly different, but around the area of 163 is what we're looking for. Okay, a travel graph. So this shows someone's distance. So how far they've traveled over a period of time. So time of day along the bottom and distance up the side. We've got traveling away from home, not traveling anywhere. Remember, a flat line shows not traveling, then traveling towards home is going back down to the line. Remember, this is the home of the person. This bit at the bottom line is the home. So Anil cycled from his home to the park. He waited in the park, then he cycled back home. Here's the distance time graph for Anil's complete journey. What time did Anil leave home? Well, it's between 9 and 9:10, so it's going to be 9:05. What distance was Anil's home to the park? So it said he stopped at the park, so this, I'm assuming, is where the park is. So you might want to draw a line that goes from there across. So the distance from his home to the park was 2, 4, 6, halfway between 6 and 8, which is going to be 7. How many minutes did Anil wait at the park? Again, what you want to do is draw some lines going straight down from each end. Across a bit. Not quite at each edge. Okay, there. And same again on the other side. So between these 2 times, so he got there at 9:35 and he left at 9:45. So he was there for 10 minutes. Is there any more to this? That's it. Okay, so that's a travel graph. Remember, the key thing with this is when you stop, the line becomes flat. Okay, it doesn't go back down when you stop, it just goes flat. The only time you go back down is if you're going home. Okay, that's when he went home. That's this part. Him going home is this part here. Him waiting in the park is that part there. Okay, conversion graphs. So use the graph to change £30 to euros. So we look along the bottom at pounds. You draw up to your line and across. Okay, so £30 is, according to our graph, going to be 40 euros. Use the graph to change 16 euros to pounds. So again, we're going to find euros. There's 10. I think each square again is worth 1. So we're going to start at 16. We're going to go across to our conversion line and then down. So we've got about 12. Okay, the line is already drawn for you. You just have to interpret the graph. Okay, and that's it for today. We've gone through a few topics, not too many. A lot of the graph work, but it just needs a bit of practice really with these. So well done. You're still cracking on. We've only got about 10 weeks left of videos and of lessons until the end of the year. So we just need to crack on with these. Maybe set some time aside and watch a video a week or a couple of videos a week, just to keep yourself updated. At the end of each week, watch back the one we've done the week before, just to keep yourself in the loop about what we're doing, and so you don't forget. Some of you are telling me that as soon as you walk out the classroom, you start forgetting, or the next day you might forget. So these videos, to help you stop doing that, okay, to prevent you from forgetting and to keep this information fresh for you. So ask yourself what you want to get at the end of the year, which is to get that pass, which is to improve. It's to improve your maths, which is just to gain some confidence in maths. And how are you going to get there? You're just going to keep working, keep watching the videos, keep attending, keep revising, keep trying your best, and you'll get there. Okay? See you next time.